Let us continue foundation chemistry, in which we will see isomers. Now we will take the compound called carboxylic acid. I will take carboxylic acid. Carboxylic acid formula is COOH. This COOH we can write it as C double bond OH. We can write this carbon will make 4 bonds. Carbon will make 4 bonds generally. So now you see this carbon, it is having 1 bond here, single bond here, double bond is there, here single bond is there, totally 4 bonds are there. Oxygen will make 2 bonds here. This oxygen makes left side 1 single bond, right side 1 single bond, totally 2 bonds. This oxygen has made a double bond, 2 bonds are there. Okay, so carboxylic acid we will write like this. So now we will take this carboxylic acid isomers. We will see. Now we will take the formula CN H2N plus 2 then O2 we will take. Cn H2N plus 2 O2 we will take. Now we have taken Cn H2N plus 2 O2 we have taken. In the place of N is equal to some number we will give. Suppose we are giving a 1. If we give N is equal to 1, what we will get? That we will see this C. Here 1 if we substitute H4 and O2 we are getting. Here in the place of N we have substituted 1. So C1. H here 1 if we substitute here 4, it is O2. So CH4O2. Now 2 oxygen atoms are there means we can say what functional groups possible. 2 oxygen atoms are there means what are the functional groups possible? Okay, 2 oxygen atoms. One is carboxylic acid, that is COOH. Carboxylic acid, one functional group. Next one is what means ester. Ester contains 2 oxygen atoms, that is COO, ester. This we can write it as C single bond O, like this we can write ester. So ester also contains 2 oxygen atoms. Ester is one functional group we can say. And carboxylic acid is one functional group. 2 oxygen atoms means like this. Sir. So for this, these 2 are possibilities there or not, we'll see. First, here 1 carbon atom is there. That carbon atom will write, and 2 oxygen atoms OOH we have written. Then remaining how many hydrogen atoms means remaining for this remaining how many hydrogen atoms? 3 hydrogen atoms. Like this compound, is it existing? No. Why it is not existing? We'll see. Here carboxylic acid we can write like this, C double bond O, OH we can write. These 3 hydrogens we cannot give to this carbon. We can't give to oxygen also. Oxygen will make 2 bonds. Therefore, this formula is not possible. Because based on this formula only we got this. This formula is not possible. That's what we are saying. Okay. So this formula is not possible. So we will alter this formula. Now we will take like this. Okay, like this we will take. Now we will substitute what in the sense N is equal to 1 we will substitute. Otherwise now we will write N is equal to 0 we will substitute. N is equal to 0 means this is leave this one. This becomes what? This becomes how much you see? N is equal to 0 if we substitute HCOOH. This we will get. Correct? N is equal to 0 if we substitute we will get like this. This is called what? This HCOOH. Where this HCOOH is there? It is present in the saliva of ant. It is present in the saliva of ant. Therefore, when ant bites us, we feel irritation because of this acid. This ant Latin name is Formica. Formica. So from this, the name of this acid is given. This Formica, from this we are taking form. Then we are including ic acid. Ic acid. That means you take complete formic, you take, and acid you include formic acid. This common name is formic acid. We are saying. Why this common name is formic acid in the sense because it is present in the saliva of ant. Then the common name is formic acid. We said what is the IUPAC name for this one, that we'll see. Now we'll see IUPAC name. This contains one carbon, therefore root word is meth. Primary suffix what you have to say? En. Secondary suffix what you have to say? Oic acid. Secondary suffix you have to say oic acid, you have to say. Here in this oic acid, first letter is O, that is vowel sound. Vowel sound is there means in the primary suffix the last letter E you have to drop. Therefore we will call this is as a methanoic acid. This is what means methanoic acid, we can say. IUPAC name is methanoic acid. So for HCOOH, common name is formic acid, we can say. IUPAC name we can say methanoic acid, we can say. Next, here we can say, we can substitute N is equal to 1. N is equal to 1 if you substitute, what you will get, do you know? CH3COOH. CH3COOH you will get. Here, what is the functional group present? Carboxylic acid is present. COOH means you have to say carboxylic acid is the functional group. Okay, sir. The CH3COOH, where it is present? Do we use this? Means it is present in the vinegar. Vinegar we are using. Vinegar is what? For what sake we are using vinegar? For vinegar is used as a preservative for the pickles. So vinegar is what? Vinegar contains dilute solution of this acid. Dilute solution of this acid. This acid is named as acetic acid. Acetic acid. It is named from a Latin word. Latin word for this is acetum. Acetum. Latin word for this is acetum. From that acet is taken, ic acid is included. Therefore, we are saying this acid is acetic acid, we are saying. Its IUPAC name we will see. Its IUPAC name. This contains 2 carbon atoms, therefore root word is eth. Primary suffix you have to say en. Then secondary suffix. What is the secondary suffix for this one? Means oic acid. Oic acid. In the oic acid, first letter is vowel sound O. So in the primary suffix, the last letter E you have to drop. Therefore, you will get what means ethanoic acid you will get. Ethanoic acid we are getting. Okay. Therefore, for this IUPAC name we are saying ethanoic acid. Common name we are saying acetic acid. Okay. Now, for acetic acid, can we write any isomers? For acetic acid, can we write any isomers? That we will see. Now, this acetic acid structural formula we will see first. Here 2 carbon atoms present. The 2 carbon atoms we will write like this. This carbon is having 3 hydrogen atoms. 1 hydrogen, 2nd hydrogen, 3rd hydrogen. This carboxylic acid, how to write? 1 carbon double bond O, like this we have to write. Then carbon single bond O, single bond H we have to write. Carboxylic acid we have to write in this way only. Next, for this acetic acid, is there any isomer? That we will see. Is there any isomer or not, we will see. Now for that case, what shall we do in the sense, let us interchange two things. One is this H, another one is this CH3. Let us bring this H to this place. Let us take this CH3, this carbon, to this place. Like this we will interchange. So what we will get, we will see. So to this place H comes, this COO we will write COO. Okay, to this place which comes means CH3. Okay, so we are writing this is as HCOOCH3. What is this called? It is called ester. This we will call it as ester. We will call this is as what? Ester. So here what is the functional group present? Ester is a functional group. This functional group we will call it as ester. This functional group we are calling as ester. Here functional group, this functional group we are calling as carboxylic acid. This functional group is called carboxylic acid. This functional group is called ester. So this carboxylic acid and ester, you see, for this one and this one, you see the molecular formula, how it is there. Molecular formula remains same or not? Remains same. Molecular formula is same, but what is different? Functional group is different. Here functional group is carboxylic acid. Here functional group is ester. Functional group is different. Therefore, these two are called functional isomers. Functional isomers we can say. For carboxylic acid, what is the functional isomer? Ester. For ester, what is the functional isomer? Carboxylic acid we can say. So we can say that carboxylic acid and ester are functional groups, functional isomers. For carboxylic acid, functional isomer ester we can say. For ester, functional isomer carboxylic acid we can say. Now we will see carboxylic acid ester isomers we will see. Next, N is equal to 2 we will substitute. So we are getting C2H5COH. C2H5COH. For this, we will write structural formula. Here C2, 2 carbons are written like this. In the C2H5, between carbon atoms, single bond will be there. Then the COH will write C11OOH. This C2 contains H5, 5 hydrogens. Those 5 hydrogens give to these 2 carbons. How many we have to give to each? That based on covalency of carbon. For carbon, what is the valency? 4. As per that, you give it. So here this carbon is having 1 bond. So it is in need of remaining 3 more bonds to get 4 covalency. So give 3 hydrogens to this carbon. To this carbon, give 2 hydrogens. Okay, so we can write this as this carbon is having 3 hydrogens, so CH3. This carbon is having 2 hydrogens, so CH2. This is what means COOH. Okay, carboxylic acid we have written. For this carboxylic acid, let us take IUPAC name. This contains 3 carbon atoms, therefore prop. Primary suffix is CN, secondary suffix is OIC acid. So propanoic acid is the name of this compound. For this, let us write ester. Okay, how to write ester we'll see. Take this H to this place, take this C2H5 to this place. Okay, so HCOO, C2H5 we are bringing this side. We have brought C2H5 here. Okay, we are taking this H to this place, the C2H5 to this place we have taken. Like this we got. For this ester, how to say the name? That we'll see. First, you say the name of this. The group which is attached to ester oxygen, that name you say. This contains 2 carbon atoms, therefore eth, and include YL, ethyl. Then say the name of this. This contains 1 carbon, therefore meth. Primary suffix en. That last letter E is there, no, that drop it. For ester, secondary suffix is what means O8. For ester, secondary suffix is O8. So ethyl methanoate. Then for this ester, we can write isomer. For this ester, we can write isomer. For this ester, we are writing isomer. How we are writing isomer? You see, we are writing a ester. We will write first C double bond O O. Okay. Oxygen will make 2 bonds. Therefore, the left side 1 bond, right side 1 bond. Carbon will make 4 bonds. So we have written like this. Here 2 carbon atoms are there. That 2 carbon atoms, 1 carbon you give here, 1 carbon you give here. Then give hydrogens. For this carbon, 3 hydrogens. For this carbon, 3 hydrogens. Okay, you have given hydrogens. This is also ester. In this ester, this group is bonded with the oxygen of ester. The group which is bonded with the oxygen of ester, you say name first. That name first. This contains 1 carbon, therefore meth. Then include ON, methyl. This remaining thing contains 2 carbon atoms. That 2 carbon atoms means eth, that you write. Primary suffix en you write. Drop E. Then the COO name is what in the sense O8. That O8 include. So methyl ethanoate. We can say the name of this one is methyl ethanoate. We can say. Now, this methyl ethanoate and ethyl ethanoate, are they isomers? What do you think? Methyl ethanoate and ethyl ethanoate, are they isomers? We will check. Here we will see the functional group, that is ester. Here we will see the functional group, that is ester. This functional group ester, right side you see what is there, ethyl. This functional group ester, right side you see what is there, methyl. So right side of this functional group, are different. Similarly, left side of this functional group, is different. Therefore, these two are called which isomers? Metamers. Metamerism, we can say. These two are metamers, we can say. This isomerism is called a metamerism, we can say. Then here functional group is carboxylic acid, here functional group is ester. Therefore, these two are functional isomers. What is meant by functional isomers? Functional group will be different. That is functional isomers. Here functional group is carboxylic acid. Here functional group is ester. Therefore, these two are functional isomers. What about these two? These two also called functional isomers because functional group is different. Therefore, these two are called functional isomers, we can say. Correct? So, now, in the place of 2, we will write 3 now. What are the isomers possible that we will see? So, C3H7COH. For this, what are the isomers possible that we will see? 3 carbon atoms are there. These 3 carbon atoms we will write straight. This carboxylic acid I will write like this. Now, out of 3 carbons, 1 carbon I will write a branch of this. So, I can write like this. Okay, 1 carbon atom we are writing branch for this. Then give hydrogens. We are giving hydrogens. Here 3 hydrogens. Here 2 hydrogens. Here 2 hydrogens. Here 3 hydrogens. Here 3 hydrogens. Here 1 hydrogen. Okay, we have written carboxylic acids. We have written possible structures for carboxylic acids. We have written. For this carboxylic acids, let us say the IUPAC name. For first compound, IUPAC name is what we will see. The first compound is having 4 carbons in the parent chain. In the parent chain, 4 carbon atoms are there. Therefore, but. Primary suffix en. In the primary suffix en, drop E. For carboxylic acid, secondary suffix we can say oic acid. So it is called butanoic acid. For this case, let us select parent chain first. It is a parent chain. Now this CH3 is not present in parent chain, therefore it is treated as branch. This branch name is what means methyl. Now parent chain contains 3 carbon atoms, therefore prop. Primary suffix is en. In the primary suffix last letter e, drop it. Then secondary suffix is what means oic acid. So we can call this as methyl propanoic acid. Then let us say the position of branch. For saying position of branch, give the numbering in the parent chain. In the parent chain, how to start numbering means carboxylic carbon must get least position. Therefore, carboxylic carbon we are giving number 1, then number 2, number 3. Now branch is attached to second carbon, therefore we are saying 2-methyl propanoic acid for this. So we have written carboxylic acids, we have written here. Next, we will write for carboxylic acid functional isomer. What is that? Means ester. Now we will write ester. We will write. We are going for ester. Now how to write ester in the sense ester means you write C double bond O, single bond O. Right side of O, one bond you give it. Right, left side of carbon you give one bond. This side you write some group. This side you write some group. Okay. Now what I will write means one side I will write hydrogen. In the rest of the side I will write 3 carbons. I will write 3 carbons. 1, 2, 3. 3 carbons I have written. Then I will give hydrogens for this carbon, 2 hydrogens, for this carbon, 2 hydrogens, for this carbon, 3 hydrogens I have given. Then what I will do means this carbon I will write it as branch for this carbon. Okay. So now H, C, O, here C, here C, here C. This carbon I will write it as a branch for this carbon like this. Now I will give hydrogens for this carbon 3, for this carbon 3, for this carbon 1. Like this I have written. Next, what can we do in the sense here this COO I will write, ester I will write, C double bond O I will write. Here 3 carbons are there. That 3 carbons I will distribute 2 carbons this side and 1 carbon this side I will write. Then I will give hydrogens, here 3 hydrogens, here 2 hydrogens, here 3 hydrogens I have given. Like this I have written. Is there any more possibility? Sorry, okay. Now we will say the name of these compounds. We will say now for ester, it is ester. In the ester, how to say the name in the sense in the ester, the group which is bonded directly with the oxygen, that name we have to say first. Therefore, we have to say the name of this one. This is called, this contains 3 carbon atoms. Therefore, prop you say and include YL. Propyl you have to say. Then this left side contains 1 carbon. 1 carbon means meth you have to say, primary suffix en and secondary suffix O8. In the primary suffix en, last letter E we have dropped and the secondary suffix for ester is O8. Therefore, it is called propyl methanoate. This is called what? Propyl methanoate. Then we are going for this compound. In this compound, it is ester. In the ester, it is oxygen. This oxygen is having this group. So say the name of this group. This group contains 3 carbon atoms. Therefore, we are saying prop. We said prop. Then include YL, propyl. Okay, we said propyl. Then this ester contains 1 carbon atom. Therefore, meth and the primary suffix en. In that last letter E, you drop it and write O8. O8 is the secondary suffix for what means a functional group ester. So we can call this is as a propyl methanoate. Now you see this compound and this compound, you see for both compounds we have given propyl methanoate is the name, but structure is different. How the structure is different in the sense here we can say the first carbon is linking with the ester oxygen, but here second carbon is linked with the ester oxygen. Therefore, you say the position you say. Okay, position means here we can say 1, here 2, here 3. First carbon is linking with the ester oxygen. Here we can say it is number 1, it is number 2, it is number 3. Second carbon is linking with the ester oxygen, we can say. So that why we have given a numbering 1, 2, 3 like this. Why not reverse? That means we have to say the position, least position has to come. In that way only we have to give numbering. Okay. Therefore, start from this left here 1 you start. Don't start from this right one. Okay, so that here this propyl group and this ester, this in the propyl group first carbon is attached to ester of oxygen, that is one. This one meaning is in the propyl group first carbon is attached to ester of oxygen, that is a meaning. Here what we have to say means 2, we have to say 2 propyl, that means in propyl second carbon is linked with the ester of oxygen, that is a meaning. In the propyl second carbon is linked with the ester of oxygen, that is a meaning here. Okay, now the name is 1 propyl methanoate, it is 2 propyl methanoate, we can say. Now we will take this one here, how to say the name. In this case this ester is this one. In the ester it is the oxygen. This oxygen is directly linked with a group. This group name only we have to say first. Okay, so ester in which oxygen you take, that oxygen is directly linked with which group you say, that group name we have to say first. This group contains 1 carbon, therefore we will say meth, we will say, then include YL, methyl you say. Then rest of the things you take, rest of the things this one. In the rest of the thing 3 carbon atoms are there. 3 carbon atoms means we can say prop, primary suffix en we can say. In the en last letter E you drop it, and ester is a functional group. Functional group ester is O8 you have to say as secondary suffix. So the name of this one is methyl propanoate. We said like this. Now we have written for this C3H7COH, what are the possible isomers? That isomers we have written. Next, we have to say which isomers these are. Isomers in the sense chain isomers, position isomers, functional isomers, metamers, tautomers, like this is there. These are coming under which isomers? That point we have to say. Okay, sir. Number A and B. Which isomers? In A, parent chain contains 4 carbons. In B, parent chain contains 3 carbons. Therefore, parent chain length is different in A and B. Therefore, A and B are called chain isomers. Okay, because parent chain length is different. Therefore, A, B are called parent chain isomer. That means chain isomers we can say. Then we will take A and C. Functional group is different. A, carboxylic acid, C, ester. Therefore, A and C are functional isomers. Then we'll take D. A, D, functional isomers. Then we'll take E. A, E, functional isomers. Like that, BD, BD, BC, BE, functional isomers we can say. So, next we'll see. Now, we'll take C and D. In C, first carbon is attached to ester oxygen. Here second carbon attached to ester oxygen. Therefore, CD are position isomers. Position is different. Here position is 1, here position is 2. So position is different. Therefore, position isomers. Now DE we will see. In the DE we will take, in the D we will take functional group ester. In the E we will take functional group ester. Here for this functional group right side methyl is present. For this functional group right side propyl is present. Isopropyl is present. So functional group right side is different. Similarly, functional group left side is different. Therefore, D and E are called metamers. Metamers we can say. Then what about C and E? C and E. Shall we call metamers? Yes. C and E we can call it as a metamers we can call. CE is called metamers. Okay. Then is there any other isomers possible for this? Any chain isomers or position isomers? Any more isomers shall we say? Okay, that's all. Likewise, you can write here C4H9COH you can take. You can try for like this different isomers you can try. Okay. We will go for next isomers we will see. Now I will take what is the formula in the sense Cn H2n plus 1 NH2, like this I will take. Okay. Now I will substitute n is equal to how much means minimum 1 you have to substitute. Suppose n is equal to 0, if you substitute what will happen, that also we'll see. N is equal to 0, if you substitute it will become what in the sense HNH2. HNH2 we can write it as NH3. What is the name of NH3? Do you know? Ammonia. NH3 name is what? Ammonia. Ammonia in the sense it is inorganic compound. This inorganic compound, if you dissolve in water, you will get aqueous solution of ammonium hydroxide that is acting as a weak base, we can say. Set. Now n is equal to 1, we will take n is equal to 1 means what we can say means CH3NH2. CH3NH2. This CH3NH2, what is the name we will see? CH3 name is methyl. CH3 name is methyl. NH2 name is amine. NH2 name is amine. Therefore, the name of CH3NH2 is called methyl amine. It is organic compound. For this, we can say IUPAC name. For this methyl amine, let us say IUPAC name. How to say IUPAC name means it contains one carbon atom. Therefore, meth. One carbon atom means meth. Primary suffix we will say as ane. Primary suffix we will say as ane. This NH2 name we can say amine. NH2 name we can say amine. Now in the amine first letter is vowel sound. Therefore in the primary suffix the last letter we are dropping. Therefore the name of this one is methanamine. The name of this one is methanamine, we can say. Next we will say that n is equal to 2 we will substitute. Here we will substitute n is equal to 2. If you substitute n is equal to 2, you will get C2H5NH2. C2H5NH2 will get. Now we will write structural formula. This here contains 2 carbon atoms. 2 carbon atoms we have written. Then NH2 will write like this. NH2. This nitrogen valence shell contains 5 electrons. 1 electron here, second electron here, third electron here, then fourth and fifth electron here. It acts as lone pair. Because these 2 electrons present in the valence shell of nitrogen are outermost shell of nitrogen but not involved in bonding, therefore these are called lone electrons. It is pair of electrons, therefore it is lone pair. Then 5 hydrogens I will distribute here 1, here 1, then here 1, here 1, here 1. Like this I have distributed. Now we have written this is what means CH3, then CH2, then NH2. Like this compound we have written. Now I will write this one in another manner. First I will write N, I will write. Then here 2 carbons are there. 1 carbon left side of N I will give. Another carbon right side of N I will give. 2 carbons I have given. Then I will write hydrogens I will write. For this carbon, this carbon will make 4 bonds. 1 bond already is there. Remaining 3 bonds with 3 hydrogen atoms. Like this I have given. For this carbon also 3 hydrogens let me give. Nitrogen in the sense it will make normally 3 bonds. 2 bonds are there. 1 more bond I have given. This I can write it as a left side carbon is having 3 hydrogens, then NH. Right side carbon is having 3 hydrogens, that I have written. CH3, NH, CH3. Okay. Now what these two are called what? These two are called what? We'll say this N is having 2 hydrogens. Therefore, this N is having 2 hydrogens. This N is directly attached to 1 carbon. Therefore, it is called primary amine. It is called primary amine. This N is having only 1 nitrogen. This N is directly attached to 2 other carbons on left side and right side. Therefore, this group is called a secondary amine, we can say. This group is called secondary amine. This group is called primary amine, we can say. This group is primary amine. This group is secondary amine, we can say. Now, for this molecular formula remains same. Therefore, these two are called isomers. Which isomers? Here functional group is primary amine. Here functional group is secondary amine. Therefore, what is different? Functional group is different. Therefore, we can say these two are called which one? Functional isomers, we can say. Okay, these two are called functional isomers. Now, let us say the name for these two compounds. First, we will say the name of this compound. In this compound, 2 carbon atoms are there. Therefore, we can say eth. Carbon single bond is there. Therefore, primary suffix en. In the primary suffix en, last letter e, I will drop it. NH2 name we will say amine. NH2 name we said amine. Therefore, this compound name is ethanamine. Next, we'll say the name of this compound. In this compound, let me say this name first. This CH3 name is what means methyl. methyl. Then this CH3 contains one carbon, that we will write it as meth, primary suffix an we will say. Then this NH name we will say as a amine. Therefore, this name is methyl methanamine. Now we can call this ethanamine and methyl methanamine are called functional isomers. Here functional group is primary amine, here functional group is secondary amine, we can say. Next, I will write N is equal to 3. Here I will write what are the isomers possible. For that we will see N is equal to 3. If you take, we will get C3H7NH2. For this, what are the possible isomers, that we will write here 3 carbon atoms are there. 3 carbon atoms I will write like this, and NH2 I will write like this. Then one carbon, write it as a branch for this. Therefore, we will write like this. We'll write like this. Okay. Then you give hydrogens. You give it hydrogens. How to give, in the sense for this carbon 3 hydrogens, for this carbon 2 hydrogens, for this carbon 2 hydrogens, for this carbon 3, for this carbon 1, for this carbon 3. Like this we have written. Okay. Then for this we can write it as it is primary amine. NH2 means primary amine. N is having 2 hydrogens. That means it is NH2. NH2 means primary amine, we can say. Now we can convert this into secondary amine. Secondary amine means what you have to do? You replace this H by one carbon. Okay. So you write NH, you write, and this side one bond, this side one bond, you give it. Nitrogen normally makes 3 bonds. Okay. Now 3 carbons are there. You give 2 carbons left side and 1 carbon you give right side. Then give hydrogens. Then we are giving hydrogens now. Here how many means 3, here how many means 2, here how many means 3. Like this we have given. It is called what, in the sense secondary amine, we can say. This is called secondary amine. Secondary amine means N will have only one hydrogen. It is called secondary amine. We can write even tertiary amine for this. That means write N, give 3 bonds. Here you give 1 carbon, here you give 1 carbon, here you give 1 carbon. Okay, it is called what means tertiary amine. Okay, it is secondary amine. Therefore, this is what means primary amine. It is primary amine, we can say. It is secondary amine, we can say. It is tertiary amine, we can say. Tertiary amine. Why do you call this as tertiary amine? Because nitrogen is not having hydrogen, and nitrogen is directly linked with the 3 other carbons. Therefore, tertiary amine. Here it is secondary amine because nitrogen is having only one nitrogen. This nitrogen is directly bonded with the 2 carbons. Therefore, secondary amine. This primary amine because nitrogen is having 2 hydrogens. It is directly attached to only 1 carbon. Therefore, primary amine. Like that we can say. Okay. Now we can, let us take this number A and number B. A and B, which isomers do you say? And C you take, and D you take. Okay. Now we will say the name of the compound first, then we will go for this one. Here 3 carbon atoms are there. Therefore, primary suffix an we can say, secondary suffix amine we can say. NH2 is the secondary suffix amine. Here also 3 carbon atoms are there. Therefore, primary suffix an, secondary suffix is amine we can say. Now position of amine, you see, in this case amine is attached to first carbon. Therefore, position of amine is 1 we can say, propane 1 amine. Here we can say it is first carbon, it is second carbon, it is third carbon. NH2 is attached to second carbon, therefore it is called propane 2 amine, we can say. So here position of amine is 1, here position of amine is 2, therefore A and B are position isomers. What about AC? Functional isomers. AD, functional isomers. BC, functional isomers. BD, functional isomers. Okay, like this we can say. So